One pipe can fill a tank in 20 minutes, while another takes 30 minutes to fill the same tank. How long would it take the two pipes together to fill the tank? So, where do you start with this problem? Well, if you notice, we are doing something at some speed. Does that sound familiar? That's how we defined our rate. A rate is doing something at some speed. Let's bring this formula down and see if it can help us. All right, with this formula, we said that we are doing something at some speed. We're doing it for some amount of time, and that allows us to get some total amount. And that amount, we said, it could be distance, or it could be the number of zombies that you shoot in a game, or the number of movies you watch. It's just some sort of amount. And in this problem, our amount would be the volume of the tank, how much we fill up that tank. So our equation in this problem is going to say volume equals rate times time. So let's think about this equation the other way. Instead of volume equals rate times time, let's say rate times time equals volume. Same idea, we're just looking at it a different way. So in this problem, we're filling a tank. And so this pipe is going to fill the tank at some rate. Let's say we're filling it with water, with liters of water. So our rate could look like liters of water per minute. So maybe one pipe fills 30 liters per minute, and the other pipe fills 50 liters per minute of water. It's a rate. We're doing something at some speed. And when you do that for a certain number of minutes, we're going to get some total volume in liters. And as you might notice, our minutes cancel out, as they should, to make sure that we have liters on both sides of our equation. Remember, something equals something else. We need to have the same units on both sides. So this is how we're going to think about this problem. I don't know exactly how to get to the answer, but this looks like something we could start with and see where it goes. But let's draw a little picture first, just to better understand this problem. So we have a tank here, and we have two pipes, and they're filling up our tank to some total volume. Let's call that V sub t for total volume. So let's take a look at our question one more time. One pipe can fill a tank in 20 minutes, while another takes 30 minutes to fill the same tank. How long would it take the two pipes together to fill the tank? Let's call this first guy pipe 1, the other guy pipe 2. Let's see if we can write something down about these two pipes. So we're told that our first pipe can fill a tank in 20 minutes. Let's see if we can put that information into our formula. So the rate that our first pipe is filling the tank, let's give that a subscript, pipe 1. The rate of pipe 1 times how long it flows, we are told 20 minutes, gets us to that total volume, which we said was V sub t. Now what did they say about pipe 2? They said pipe 2 can fill the tank in 30 minutes. So let's write a similar equation for that. Pipe 2 is going to fill the tank at some rate. We'll put the subscript pipe 2, and it's going to fill the tank for 30 minutes, which is going to lead to our total volume. Now let's consider the situation where both pipes are filling the tank at the same time. Basically what our picture looks like. So what is the rate of the water flowing into the tank? Well, it's going to be the rate of our first pipe plus the rate of our second pipe. Both pipes are flowing into the tank. And if the water flows into the tank for some amount of time, we'll get our total volume. Now we don't know what that time is. That's what the question's asking. We were told how long each pipe could individually fill the tank. And the question's asking, what if we put these two pipes together? And there's actually something neat we can do. Looking back at our first equation, if we solve this for our rate, meaning if we divide both sides by 20, we're going to get our rate of pipe 1 equals V sub t over 20. And we can do the same thing for the second equation. We'll solve for the rate of pipe 2. So we divide both sides by 30, and we'll get the rate of pipe 2 equals V sub t over 30. So now we know what the rates of pipe 1 and pipe 2 are, and we can actually substitute those values into the third equation. So we know that the rate of pipe 1 is going to be our total volume over 20, and the rate of pipe 2 is our total volume over 30. And we can fill in the rest of the equation. Now we're going to write our part in parentheses a little bit differently. V sub t over 20 is the same as V sub t times 1 over 20. So V sub t is the same as V sub t over 1, and if you multiply these two fractions, you'd get back to the piece above. So similarly, V sub t over 30 is equal to V sub t times 1 over 30. Now it kind of looks like our V sub t is multiplied by each piece on the inside, as if we use the distributive property. So we can write this a different way. We can write this whole thing in parentheses as V sub t times 1 over 20 plus 1 over 30. If we use the distributive property to multiply our V sub t to each piece on the inside, we would get to our line above. So we're just going backwards. Instead of distributing V sub t to each piece on the inside, we're actually taking it out. We would say that we're factoring out the V sub t. Now remember, we're trying to solve for our time. We want to figure out how long it takes for these two pipes to fill the tank. And if you notice, we're multiplying three pieces on the left side. We have our V sub t, our piece in parentheses, and our time. So that means we can divide both sides by V sub t. On the left side, our V sub t's cancel, and we get 1 over 20 plus 1 over 30 times our time. And on the right side, V sub t divided by V sub t is just 1. Anything divided by itself is just 1. So doing this step removed our V sub t. So what does that mean? That's telling us it doesn't matter what the volume of the tank is. It's saying if we know that one pipe fills the tank in 20 minutes and another pipe fills it in 30 minutes, that's enough information to figure out how long it would take both of them together. So let's solve for our time. In parentheses, let's get common denominators. We can get a denominator of 60. So we multiply top and bottom by 3. So we get 3 over 60. And then we need to multiply top and bottom by 2 to get 2 over 60. Adding our fractions, we get 5 over 60. And how do we get time by itself? We multiply by our fraction flipped. So it's 60 over 5 on both sides. On the left side, our 5's cancel and our 60's cancel. So that piece goes away, and we're just left with our time. And on the right side, you might notice that 60 divided by 5 is 12, and 1 times 12 is 12. So if we're using both pipes, the time it would take to fill the tank is 12 minutes. And that number should make sense. If one of our pipes takes 20 minutes and the other takes 30 minutes, well, together they should take less than either of them, right? So our number in the end should be smaller than either 20 or 30. Going up to our answer choices, that would be option D. So these problems take a lot of thinking, but you have some tools in your toolbox to help you out. If you notice the question is talking about a rate, then you can write down your distance equals rate times time, and you can make a change to the total amount to match the question. So instead of distance, we're talking about volume. You can draw a picture to better understand the problem, and you can use the picture and the formula to write down some equations about the problem. They told us that pipe 1 could fill the tank in 20 minutes, so I wrote an equation about pipe 1. They told us pipe 2 could fill it in 30 minutes, so I wrote an equation about pipe 2. Then the question was talking about putting the pipes together, so I wrote an equation there. And getting this all on paper helps to find the connections. I noticed that the rate of pipe 1 and the rate of pipe 2 were both in the third equation. So that's why I solved for each of them and plugged them in. And from there, it was pretty quick to get to the end. So when you're reading these types of problems, whether they're mixtures or distance, rate, time, it can be difficult to figure out how to get from the start to the finish. A lot of problems you've worked on, there's a pretty straightforward path to get to the finish line. But these kinds of problems, there's a bit of a winding route to get to the finish line. Not as straightforward as you're used to. But you can get to the finish line if you use the method and tools that we've learned for solving word problems. You might have noticed that I used that method and tools in this problem. I encourage you to review the video on how to approach word problems. Being able to work through this winding path is a skill. It doesn't come easily, but with time and practice, you'll get to the finish line. Two airplanes left the same airport traveling in opposite directions. If one airplane averages 400 miles per hour and the other airplane averages 250 miles per hour, in how many hours will the distance between the two planes be 1,625 miles? All right, you might see some keywords in here like distance, miles per hour, miles. So most likely we're going to need our formula. Distance equals rate times time. Let's try to visualize this problem. So we have an airport, and one plane is going in one direction. We'll call that plane 1, and the distance, we'll call that d sub 1. And the other plane is going in the opposite direction. We'll call that plane 2, and that distance will be d sub 2. And this question is talking about the distance between the planes. So from end to end, we'll call this distance the distance between, or our subscript can be dB for distance between. So this picture here, this describes our problem. We have two planes going in opposite directions, and we want to see in how many hours will the distance between the two planes be 1625 miles. So let's use our formula to write some information down about this problem and see if it can lead us to the answer. So let's think about plane 1. The distance it travels is going to be equal to the rate it travels at times the time it travels at. So we'll just have that subscript 1, just referring to plane 1. So are we given any information about the rate or the speed that this plane is traveling at? Yes, we are. We're told that the plane travels at 400 miles per hour. So we can put that information into our equation. And our rate is 400 miles per hour. And we don't know how long the plane is flying, so let's just call that t sub 1. And cleaning that up, we can write it as 400 t sub 1. That's the distance that the first plane travels. Now let's think about the second plane, t sub 2. Same idea, we have to look at the rate that that plane is flying at times the time that it flies. So are we told the rate of the second plane? Yes, we are. That's 250 miles per hour. So we can put that information into our equation. So 250. And we don't know how long that plane is flying, so let's just call it t sub 2. And we can rewrite that as 250 t sub 2. So we have some information about our picture. We know the distance the first plane is flying, and the distance the second plane is flying. Now let's take a look at our distance between. So the distance between these planes is going to be this entire distance across. And so that's made up of two pieces. That's made up of the distance of the first plane plus the distance of the second plane. So we can write that down as an equation. The distance between is going to be the distance of the first plane plus the distance of the second plane. And we already know what d1 is equal to and what d2 is equal to. So let's put that into our equation. So the distance between these two planes is going to be the distance of the first plane, which we found out is 400 times t sub 1. And t sub 1 is how long the first plane flies. Plus, we have our second plane's distance, which we found out is 250 times t sub 2, which is how long the second plane flies. Now, just a quick note about this problem. It should have told us that the airplanes left the same airport at the same time. This problem wants us to assume that, but if you read that first sentence, it's not really clear when these planes actually leave. It says 2 airplanes left the same airport traveling in opposite directions. Maybe plane 1 left an hour later than plane 2. That would still fit this description. So they should have specified that these 2 planes are leaving at the same time, because that's the only way to get to the answer they want. So if the 2 airplanes left at the same time, that means that the amount of time that they're both flying is the same. So going back to our equation, our t1 and t2 are the same. Plane 1 is traveling for the same amount of time as plane 2. So we can replace t1 and t2 with just one variable. Let's call it t. So we have 400 times t plus 250 times t. So instead of having 2 variables, we just need one. And this shows that both planes are flying for this same amount of time, t. And we can clean this up a little more. 400t plus 250t gives us 650t. So this equation says that the distance between the 2 planes is going to be 650 times the time that they're flying. Now let's review what the question's asking. It asks, in how many hours will the distance between the 2 planes be 1625 miles? So that number, we can just plug into this equation for dB. So if the distance between the 2 planes is 1625 miles, we can use this equation to solve for the time. And that'll tell us how long were these planes flying. So we want to get our t by itself. So we divide both sides by 650. That'll give us 1625 over 650 equals t. Now we can use a calculator. So 1625 divided by 650 gives us 2.5. So this tells us that after the planes fly for 2.5 hours, they will be 1625 miles apart. And looking at our answer choices, that would be A. I encourage you to think about how this problem would change if the two airplanes left at different times. For example, what if plane 2 left an hour later? How would this change the problem?